In this video, I'm going to talk a little bit more about kinetic molecular theory, specifically how the average molecular speed varies with temperature and mass of the substance. Let's first look at the distribution of speeds as a function of the temperature of the molecule. Notice that all of these curves are representing nitrogen, and they are at three different temperatures, 0, 100, and 1000 degrees Celsius. On the x-axis of our graph, we see our velocity or speed, and that's in units of meters per second. On the y-axis, this represents the amount of molecules, the amount of N2 molecules with that particular speed. So here we have more molecules at this speed, up here at the top of the peak, than we do down here at a lower portion of the peak. Now, as we increase the temperature, going from left to right, we see that the average speed increases. There is always going to be a distribution of speeds, no matter what the substance, no matter what the temperature. At lower temperature, the distribution peak is much narrower, and our average, which will be somewhere around the peak, is going to be less than what we see at 100 degrees Celsius. So as we've gone from 0 to 100 and then down to 1000, we see that our average speed is somewhere here in the middle around the peak, and it is shifted to the right, means it's increased the average speed. But notice that we still have molecules moving really slowly and molecules moving very fast. The difference is the distribution and the average as we change the temperature. Now we're looking at three different substances, all at 0 degrees Celsius, and what we see is that the mass of each of these substances is different. So the first peak we look at is nitrogen, which has a mass of our 28 AMU, or 28 grams per mole. When we look at the peak, we notice that the average speed is fairly low relative to the helium and hydrogen, and it's also a much narrower peak, but we still see a range of speeds. When I look at helium, which is here in green, I notice the peak is shift to the right, so the molecules have increased their speed. Therefore, the average molecule has increased its speed, and we also see a wider distribution of speeds in those helium atoms. And then we go to the hydrogen molecules. Again, our mass is lower, our average speed is greater, and we see a much broader distribution of speeds as we increase that average speed. This same trend will exist if we compare different substances, as long as we are comparing them all at the same temperature. We could also compare these at 100 degrees Celsius, and the peaks would look different and they would be shifted to the right, but they would still have the same relative trend. Big things move slower, small things move faster.